The start of Chapter 13 distinguishes between observational studies and experiments. So the first word is observational study. This is when behavior is only observed. Like it says in the title, it's an observational study. There's no randomization into groups. There's no manipulation of variables. And to describe any patterns that we see, we use the word association. So observational studies might be you go to your local coffee place, you sit, and you decide to watch what people order. You think because it's in the morning and maybe it's colder that people are more likely to buy hot drinks than they are cold drinks. So you're not randomizing, you're not manipulating any variables, you're just watching what's going on. Maybe we're on the second floor of our classroom. Say you look out the window at lunch, you're kind of like creeping on people and you want to see what's going on. Maybe you observe, or you're wondering where people eat in the quad, if there's some kind of pattern to how people congregate. That would also be an observational study. The book breaks it down into retrospective and prospective studies. We don't need to know that. That is not important for us. Okay, so there's observational study. After observational studies, we're going to talk about experiments. So in an experiment, unlike observational studies, there is randomization. We do manipulate variables. So one way to think about it, even though it's a harsh word, is that people or things are forced into different groups. I.e., again, variables are manipulated by the experimenter. So you've got a whole bunch of people. It's like, okay, you go watch the videos for stats. You all go read the book, and we'll compare later to see how we did on the next quiz. Something like that. So if you are manipulating variables, you've got an experiment. Might not be a good experiment, but it's an experiment. The book is going to ask us to identify experimental units or subjects. This is what we are either observing or experimenting on. So again, the objects or the people who the experiment or observational study is being conducted on. So observational studies and experiments do not always have to involve people. They can involve animals, trees, paper towels, tires, types of glass. I don't know, I just made that up because I'm looking at the window. All right. So that was our experimental units. We are going to measure something at the end of experiments or observational studies, and that's our response variable. So it's got similar characteristics to our parameter statistic before. So this is what is being measured, or the end result. We've got factors. Factors are the big variables we're interested in finding out about, especially in an experiment. So sometimes thought of as explanatory variables. There can be more than one, and it's the generic thing you're testing. So last year I experimented on my mom and my husband. I made 3 different types of cupcakes, like Betty Crocker, Duncan Hines, and like the generic Walmart brand. So one factor was cake type, and then I had 2 types of frosting. I had Betty Crocker frosting and Duncan Hines. So my other factor was frosting. So in that case, I had 2 factors, cake type, frosting. The levels are how many of each, well, let's just turn it over. It's like it sounds. So how many types of the factor are being tested or investigated. So for my cupcake experiment last year, I had 3 levels of cake type, and I had 2 levels of frosting. So they're just the specific things of the factor. So my 3 levels were Betty Crocker, Duncan Hines, Walmart brand for the cake, and my 2 levels for the frosting were Betty Crocker and Duncan Hines. So I had 3 levels of the factor cake and 2 levels of the factor frosting. to find out how many treatments there are. So how many cupcakes did my husband and my mom end up trying? You times the levels together. So 3 levels of factor 1 times 2 levels of factor 2. They ended up trying 6 different treatments. So each type of cake with each type of frosting. So they tried 6 cupcakes to determine the response variable of which one tastes the best. Just a little bit of other things that happen in experiments and that people in the real world get wrong. When is the phrase cause and effect or saying there's a causal relationship okay? So the only time it's okay to say that one thing causes something else is when you've done a well-designed, good experiment. If you're doing an observational study, you can't say one thing causes the other. A weird thing about this is you really can't say that smoking causes lung cancer. There's been no experiments done on lung cancer and smoking. You can't randomize people into a smoking group and a non-smoking group due to ethical concerns. You wouldn't want to get a bunch of people and say, hey, you've been randomly assigned to smoke for 20 years. So that's technically an observational study. So you really are not supposed to say that smoking causes lung cancer. There's perhaps a high association, but not cause and effect. And finally, just leading into tomorrow, the 3 items necessary for a good experiment, because we just mentioned when can you use cause and effect. It's when you've got a good experiment. So what do you need for a good experiment? And we'll talk more about this tomorrow. But for a good experiment, you need randomization, you need replication, and you need control. So those are the big 3 things that must be present for there to be a good experiment going on. That is the end of Chapter 13, Part 1.